Okay, so I want to connect together for you something old to something new. This is page 24 in your packet, okay? So we're going to connect together box plots and your normal curves. And so we're going to start by drawing a normal curve like this. And then we're going to put the z-scores in. So we're going to put our 0, 1, 2, 3. Okay. -1, -2, -3. All right. So I want to get a box plot superimposed on this. And so what are the things that we graph on a box plot? Median. Okay, good. Where is the median located?
0.
Okay, very good. Since this is symmetrical, the median will be right here. Okay, nice. All right, what else would we be interested in finding on Q1? Okay, so Q1 will be located at where? Yes, Q1 is at the 25th percentile. Well, where's that on here? What z-score would that be? It's going to be at the 25th percentile. That means 25% is below it. So, good. So I'm going to get that -0.6745 by doing inverse norm of the area below is the z at that spot. Okay? All right. So I want to draw that on here. Where would that go?
Like in the middle of 0.
Okay, about 2/3 of the way. Would you say about 2/3 of the way between 0 to -1? So here is where my Q1 is going to be located. And then by symmetry, my Q3 is in what percentile? Since it's at the 75th percentile, then I'm going to do inverse norm of it 75% below it. Okay, and where's that going to put me without even calculating it? It's going to be the positive 0.6745. So it will be about right here. And so there's our Q3. So here is where 50% of our data is located. Okay, on a normal curve. Now, I want to make another connection for you. If I did my norm CDF from my Q1 to my Q3, that will give me the area from Q1 to Q3. How much area should it be from Q1 to Q3? It should be 50%. Well, look, I've already got it queued up here on my calculator. And right here, norm CDF from Q1 to Q3 is 50%. Okay? I want to make one more connection for you. It should make sense that you don't go all the way out to 1 standard deviation. It should make sense that this Q1 to Q3 is here closely clustered around the mean, because technically, how much area is from 1 standard deviation down to 1 standard deviation up? 68%, right. But a box plot only has 50% in it. So that's another reason why this Q1 and Q3 is not all the way out to 1 standard deviation up and 1 standard deviation down. Okay, so then I don't know exactly where the whiskers would go to. They would go to whatever your data is, and depending on if you had outliers and such. So we won't go to that detail. All right, so let's apply this. Here we go. John Bill of Stanford, California, recorded the speeds of cars driving past his house, where the speed limit read 20 miles per hour. The average reading was 23.84 miles per hour, with a standard deviation of 3.56 miles per hour. Draw and label a normal model distribution of these readings. Okay. So what I want to show you here is what I want to be in a complete drawing. We've kind of talked about it before. Um, this will be on your warm-up and on your quiz tomorrow also. Okay, so let's make sure we understand the things I want included. You will first draw your little normal curve, and one line down here will be representative of the z-scores, and one line will be representing the context. What is the context of these problems? Of this problem? Speed. And the speed is going to be given to me in values that are miles per hour. Okay? And so now, let's go put in our 0, 1, 2, 3, and -1, -2, -3. Those are our z-scores. Okay? Next, I want to put in my context ones. Okay? So, what will go right here at the 0 spot? Good. This is going to be my 23.84. And so then how will I compute that going up and down? Good. Just add your standard deviations up and then subtract them down. So I'm going to add 3.56 and I get 27.4. Add 3.56 and I get 30.96, and so on. So I'll put these in here real quickly. As long as you understand what's happening, I'm pretty sure you can add and subtract. So I'll give you those numbers quickly. 16.72 is 2 down, and 13.16. Okay. And the final thing I want you to do is put your percentiles on here. Just the 3 main percentiles of 1 standard deviation away from the mean is how much data? 68%. 2 standard deviations around the mean is how much data? 95%. Good. And then 3 standard deviations is 99.7%. Okay, so those are the 3 things that I want you to put down on a normal curve when you're going to be drawing it on your warm-up and on your quiz. And if I say draw a full normal curve, that's what I'm going for. And I don't need to box on it, yeah. Okay, let's move on. Let's get some summary data here. Q1, median, Q3, and IQR. Well, what's the median? Let's do that one. That one's first. Very good. The median is the same as the mean, which is the 23.84. Labeled context miles per hour, because that's what it's wanting here. Okay, so what miles per hour is the Q1 at? How am I going to... It's right in here somewhere. It's right here in this section, and... Oh, wait, my bad. Here, Q1 is somewhere right here, and Q3 is somewhere right here. How can I figure that out? Correct. So what you're going with, what I hear you both saying, is it has to do with your z-score, how many standard deviations you are away. Okay? So if you're a common sense person, then you're going to be doing this. You're going to be saying the mean minus that many standard deviations. Okay, so, but if you're not a common sense person and you just like the formula would look like this. Your Q1, the z-score of your Q1 is negative 0.6745. And what we want to know from that is x. And we know the mean, x minus the mean, over the standard deviation. And then you get to solve for that value. Just doing algebra. label miles per hour because it's context. Okay? So I want to give you a minute to do Q3 on your own and the IQR. Okay, so do that real quick, and I'm going to actually come start stamping. Check and see how you did. Your Q3 value came out to what? Yep, 26.24 miles per hour. You set up with a Q3 Z-score of positive 0.6745. And so then for your IQR, you just did your subtracting of your Q3 minus your Q1, and you got 4.8 miles per hour. Context, context, context. Okay, so now page 20 or page 25 is the back, and it's got two other little things right here that I want you to do. So I'll come around